Okay, so we have started recording this revision of our exam one. Uh, I will share my screen with you now. So for the exam one, we have chapter 1, 2, 3, 4, 5, and 8. Okay. So introduction to operations management, that's fairly simple. I'll not really go over it. I'll start with chapter 2. Which discusses competitiveness, strategy, and productivity. Okay. Now, if I scroll down, again, I'll not go through the whole slide. I'll focus on some specific points or specific areas of the course which might help you. Okay. So over here we have the mathematical model, and typically you get some questions from this. Productivity is output by input. So you should always remember the input comes in the denominator and the output in the numerator. So if the more the output, the more is the productivity. That's what you should remember. So again, I'm repeating it, more is the output, more is the productivity. So if a question says that the output increases from 100 to 120, is the productivity increasing or decreasing? The answer is increasing because output is in the numerator. Now, output can be measured as a single unit output. Uh, the same with the input. Input can be a single unit input. What do I mean by that? Input can be labor, it can be capital, it can be machine. So those are single unit inputs. Or if it is a multi-factor productivity, each of these units or each of these inputs are converted into dollar value, and we sum them up in the denominator. The output is also in the dollar value, and we get a ratio. So if it is in the dollar value, we'll get a ratio. The dollar will cancel out. If it is in terms of units of item being produced, so then it will have a specific unit of measurement. So these are the two main differences. One is partial measure, where we use one single unit as the input. And if it's a multi-factor productivity, we include in the denominator all the factors which goes into production, like labor, machine, it can be overheads. And there are some problems in the text, some worked out problems. You should all go through it. Now here is again an example of multi-factor productivity. Make yourself familiar with this example. Okay, if you can solve this problem, you'll be solving a big part of the problem which can come from this chapter maybe. Okay. There are a few other problems which are taken from the text. Try to look into some of those. Again, the problem which I'll give may not be the exact number, but you should develop that concept. Next chapter, what we have is, let me get the syllabus here. So that was competitiveness, strategy, and productivity. The next chapter is forecasting. Now, forecasting is probably one of the most difficult chapter all our students faces. That's because there are a number of numerical problems from this chapter on forecasting. First and foremost, you should understand, why do you need forecasting? Say you are manager of a pizza store. you have to plan in ahead how much of raw material you'll be needing for the next week. So in order to do that, you have to forecast the demand. So is forecasting accurate? No. You are just trying to make a guess. But again, you're making an educated guess. And over here, you are using some numbers to make that guess. So the objective of forecasting is to be as accurate as possible. So again, you are never perfectly correct in forecasting, but you try to be as close to the actual as possible. Now, as I said, forecasting is always wrong. So these are some of the measures of forecasting. One is called MAD, mean absolute deviation. Then you have the mean square error and the mean absolute percentage error. Okay, and you have the models over there. Now the question can come, why do you take the absolute value? Say in one forecast, you are on the higher side. So your forecast is more. So we measure the error by subtracting the forecast from the actual. So if the forecast is more, your error is negative. On the other hand, if your forecast is less, the error is positive. So you make 5 different forecasts, and it can so happen that they cancel out each other. One is positive, other is negative, and you might get a 0 value. So that does it mean you are doing a great forecast? No. They're canceling out one another. So what you should do, I don't know whether you understood that or not. Let me open a pen and write it down. Say you have actual and you have forecast. I'll give you a small example. So the actual demand is 5. You made a forecast of 4. And E is the error. So what is the error here? It is actual minus forecast, which is 1. Next period or next week, you make a forecast of 6 when your actual was maybe 8. So what is the error here? Error is 2. Okay. Let me write in between so we'll have space in the end. So say in the second period, you had a actual of 4, but you made a forecast of 7. What is the error here? Again, error is actual minus forecast. So error is -3. If you sum it up, sum up all the error, you get a 0. A 0 error means a perfect forecast. But is that correct? Are we making a perfect forecast? Actually not. We made error in each of your forecasting. So to avoid this problem, what we do is we take the absolute value of the error. We take the absolute value of the error. So this becomes 1. So positive is always positive. Negative becomes positive, and positive stays positive. Now, if you sum it up now, you get a sum of 6. If you divide that, so what was the formula for over here? It says MAD, mean absolute deviation. So you sum up the absolute and divide by n. So over here, n is 3. So your average error is 2. Okay, I hope you got the significance of taking that absolute. Otherwise, you get a wrong result. So over here, we take the absolute value, or else we can do a square. We can do square because square gets rid of the sign. If it's a negative value, you square it, it becomes positive. Okay, then you sum it up and divide it by n minus 1. Okay, so this is one technique, or these are three different techniques of estimating error. Okay, so I'll move forward. Now, forecasting, there are 4 different techniques of forecasting which are discussed here. One is the knife technique. So in the knife technique, you basically you don't do much of math. It's a thumb rule. So tomorrow's demand will be the same as today's actual, or tomorrow's forecast would be the same as today's actual. So this is called a knife technique. You don't do much math, but sometimes this works. How many people are going to come tomorrow? You just try to sum up or try to understand how many people have come today. So today 50 people turned up in your restaurant. So tomorrow's forecast will again be 50. And this might work with you. So this is called the knife technique. The next technique is called the moving average. So if you sum up 3 days actual, that becomes the forecast for the next period. So the forecast for Saturday would be the actual for Wednesday, Thursday, and Friday. So this is called a 3-period moving average. So you can have 3-period moving average, you can have a 4-period moving average, whatever. But it is basically an average of a few actual data. So once you sum them up, average it, that becomes the forecast for the next period. Next, we have the weighted average. In the weighted average, the concept is you give some weightage to the actual value and you give more weightage to current record. So as I said, you want to do the forecasting for Saturday, then you will have the data for, if it is a 3-period moving average, you'll have the data for Wednesday, Thursday, and Friday, and you will give more weightage to Friday, less weightage to Thursday, and the least weightage to Wednesday. Does it make sense? So this is what you should remember. Students often make that mistake. The highest weightage is to be given to the current record, and the least weightage is to be given to the oldest record. And that's the way you calculate the weighted average. Next, you have the exponential smoothing. What is it? So forecast for time period T is the forecast for the previous period plus alpha times error. So forecast for Saturday, forecast for tomorrow is today's forecast plus today's error. So this alpha t minus 1 minus ft minus 1, this is the error term, and you multiply that with this alpha. What is alpha? Alpha is a coefficient which can have a value from say 0.1 to 0.9. So, and again, for your examination point of view, I'll be giving you this value of alpha. Or it might so happen you have to calculate alpha, but the rest should be given. Okay, so you have to just manipulate the formula and calculate what is the value of alpha. So for this formula over here, I'm just explaining you with more practical terms. So forecast for Saturday is forecast for Friday plus alpha times the error for Friday. So this T is the time period, and T minus 1 is the time period before that, one step before that. So this is an important technique of forecasting, exponential smoothing. So all this this is not required. You don't have to estimate the slope and the intercept. These are done by any normal, maybe Excel or any other software. So if you have those values, if you have a series of values, Excel will estimate the slope and the y-intercept. So if you remember the equation of a line, y equal to mx plus c or y equal to mx plus a, whatever. So you have the y-intercept and you have the slope. So if you take this formula over here, so this is a linear trend. In a linear trend, you have time on the x-axis and the forecasted value on the y-axis. This a over here is the y-intercept, which is the value of ft at time period 0, and b is the slope of the line. Now you don't have to estimate the slope. We'll be providing you the value, but you have to plug in those values and calculate. So you should have the basic concept how this works. Okay. So that is pretty much all from this chapter. Next. So I discussed forecasting. I'll move over to chapter 8, which is on location planning and analysis. I'm just covering these chapters because they have some numerical problems and students face difficulties in doing those. Because in the exam, the values which are there will be different from some of the examples you have done. So please work out some of those problems. So cost, profit, volume analysis. You have 4 locations, location A, B, C, D. You have some fixed cost and a variable cost. Fixed cost is incurred irrespective of how much you produce or how much you use it. The variable cost changes. Okay. So this graph over here shows that when the production is low, so it is less than, say, 5,000 units. This x-axis is in 1,000 units. So when the production is less than 5,000 units, this green line over here, which is B, that is the best option. Why that is the best option? That's primarily because the fixed cost for A was low. But again, B has a high variable cost. So that when the production increases, B is no more the best option. If the production is more than 11,000 units, A becomes the best option. Why? Even though A has a very high fixed cost, but its variable cost is low. Okay, so A over here, it had a high fixed cost, but its variable cost, which is represented by the slope of that line, is low. So in the long run, that is a better option. So that's what is worked out here. You should understand the concept of break-even point. So you have a fixed cost and a variable cost. At certain point, your profit is 0. At certain production level, your profit is 0. So you might be asked to find out what is that point where there is a break even. The break even means your profit is zero. Then you have this multi-factor analysis where you have two alternatives, A and B, and you are given some weightage to each of those. So what you have to do is to multiply those weights with the alternatives, sum it up, and whichever is more, that is a better option. So you want to rent a place to start an office complex. So you can have different factors like the size of the store, um, the traffic volume, how much customers you expect at that location. You have operating cost. So there can be multiple factors to decide a place for your business. But each of them may not be equally important. For you, having more customer is more important. So you'll probably give it a more weightage, a bigger weightage. And you multiply those factors with the weightage, and you calculate what is the total factor rating. And then you can decide which is a better option. This is a gravity model. What does this mean? Let me again go back to that, the paintbrush. Hold on. So you have three different points, or you have four different points. Say this one, X1 and Y1. You can again assume this to be the latitude and the longitude, X2 and Y2. X3, Y3, X4, Y4. So you have, maybe these are the source of raw material. So A and B are the source of raw material. C and D, these are location of your customers. You want to locate a factory in such a way, this is your small factory close to our campus in South Dallas. Okay. So you are getting raw materials and you are shipping those out to your customers. Excuse me for this very crude drawing. So you want to locate your factory in such a way that you are at the center of all these four locations. So this location, this factory has a coordinate of X and Y. So how do you calculate that X and Y? So X is the average of all the different X's. That means X1 plus, sorry, excuse me, X1 plus X2 plus X3 plus X4. And you divide it by 4. Okay, so it's the average of all the X's. Similarly with Y, Y is the average of all the Y's. In this way, you can find out the center of location of all these 4 points. But if these locations, if this has got, let me go back to the next slide. So you got some shipment from each of these locations, and they may not be equal. They might be different. So you get Q1, you get Q1 amount from A, Q2 amount from B, Q3 amount from C, and Q4 from D. So in that case, you have to multiply X1, Q1, X2, Q2, X3, Q3, and X4, Q4, and divide it by Q1 plus Q2 plus Q3 plus Q4. Okay, this is more like giving it an weightage. So there are some problems here. You should try to solve those. And so we are multiplying with Q and dividing by the sum of the Q. So that's all we are doing. Okay, I'll stop sharing here. I hope you got some understanding of the mathematical techniques behind the 3D. We basically talked about the chapter 2, then a chapter on forecasting, and the other one was locating a facility. Okay, so I think we covered the big part of the numerical problems which might come in your exam. I'll stop the recording here, and if you have any difficulty, you should get in touch with me before the exam. Let me stop the recording.